So here's another way to deal with equations when they involve fractions. As we saw in that last example, they get really hairy very quickly. So this method actually involves, just like our decimals earlier, it's going to involve removing all the fractions in the very first step. And again, I put it in quotes because removing it by multiplying all terms, right, similar language that we saw in the last one, by, in this case, the LCM, the lowest common multiple, or we often call it the common denominator. So let's see what that looks like in this next example. Okay, so now we have an example that just has one fraction in it, right? We just have 4/5 x. We'll look at a more complicated one here in a moment. But for something like this, what we're going to do is we're going to take every term, just to go back to that language of terms, we're going to multiply every term by the common denominator. Well, since we only have one fraction and the denominator is a 5, we're just going to multiply all terms by 5. And so let's see what that would look like. So we're going to take 4/5 x and we're going to multiply it by 5. And I'll put it in brackets here in white. But remember, with brackets, it just means multiply. So we're going to do the same with the 3. It's going to get multiplied by 5. And we have to do the same to the 7. A lot of people leave out one side of an equation. You got to make sure every single term gets multiplied, and that includes the 7 over there. So now we're going to have to simplify all of these terms. We'll start with the 4/5 x times 5. If it helps, think of the 5 as a fraction. 5 over 1, right? We can write any number over 1. And then we're just multiplying numerator by numerator and denominator by denominator. So we would get 20 over 5x. And then we'd have plus, and then 3 times 5, that's just 15. 7 times 5, that's just 35. And now, I promised you we're going to get rid of the fractions because, no, look at that, 20 over 5, that's really just 4, right? 5 goes into 20 4 times. So we're going to rewrite this as 4x plus 15 equals 35. And hey, look at that, now we have an equation where the fractions are gone. We just have whole numbers, in fact, and all we're going to do is just solve as normal to get x by itself. So we'll subtract 15, I'll write it over here, minus 15 minus 15, and those two will cancel. So it'll leave us with 4x equals 35 minus 15 is 20. Then we're going to divide both sides by 4, just like we would have before. These cancel, leaves us just with an x on the left, and 20 over 4, that's 5. So x equals 5. Just for fun, we'll put this back into the equation in the very first step. We haven't done this in a little while. Let's check our answer to make sure that that works out. So I'll write it up here, a little check step. Okay, so we have 4/5 x plus 3 equals 7. So we'll go back to our original equation. We're going to substitute a 5 into the place of x. So we'll have 4 over 5 times x, which is 5, plus 3 equals 7. Well, hey, have a look at this. 4 over 5 times 5, that's multiplying two fractions. You can imagine that 5 over 1, right? And then it kind of looks similar to the step that we did down here. 4 times 5 is 20, right, if we multiply our two numerators. And then 20 over 5 is 4. So we end up with 4 plus 3 equals 7. We end up with 7 equals 7. Hey, that tells us that our 5 that we got down here is indeed correct. Now in that last example, it was a little bit friendlier on us because we only had one fraction to deal with. So finding the common denominator, well, it was easy. There was just one fraction to deal with. Now we have multiple fractions, but we just look at all those denominators. 4, 5, 5, 4. Well, the common denominator between all of those would be 20, right? Imagine trying to add those two fractions together with a 4 and a 5 on the denominator. Well, you'd say you'd want to find a common denominator of 20. So what we'll do is we'll take every term and we'll multiply it by 20. And so let's write that out. We're going to have 3/4 x times 20 minus 12 over 5 times 20 equals 8 over 5 times 20 and minus 5/4 x times 20. Okay, now we have a lot of fractions to simplify here. I'll show you just one little trick, right? And when you're solving these, what we can do is we can, what we're going to be doing in this one, for example, is we're going to be taking 20, timesing it by 3, and then dividing by 4. But one little trick when you're working with fractions this way is, if you prefer, you can take the 20, divide it by 4 first, and then times it by 3. And just to save time and effort, let's do that method for all of these fractions. So we'll step through this. 20 divided by 4 is 5. And then we're going to take 5 and we're going to times it by 3. Well, that's 15. So we'll have 15x, because we can't forget about our x that's in here. Okay, let's walk through this on the next one. We're going to take 20, divide it by 5, that's 4. And then we're going to take 4 and we're going to times it by 12. Okay, that's going to be minus 48. 4 times 12 is 48. Next, on the right-hand side, we're going to take 20, divide it by 5, that's 4. And then we're going to take 4 and times it by 8. That gives us 32. And then on the last one, 20 divided by 4 is 5. 5 times 5 is 25. So we get minus 25x. Now we have a question that looks a lot like the equations that we did before. We're going to aim to get x by itself, so I'll just jot this in. We're going to, I'll add 25x to both sides. So we'll do the same over here. Okay, these two will cancel out. So it'll leave us with 40x minus 48 equals 32. And then we'll add 48 to both sides. These two are going to cancel out, and it's going to leave us with 40x equals, well, 32 plus 48 looks like 80. And all that gross work that we did up there is going to work out quite nicely, because now we divide by 40 on both sides, and it's going to leave us with x equals 2. Now, that wasn't the easiest process getting to this point, but I hope you can just imagine trying to find that common denominator, right, of 20 between these numbers, these denominators here, and actually going through it, that process of adding those fractions and subtracting the fractions as need be to rearrange, right? When we rearranged in this step, starting here, we just had whole numbers and life was a lot easier. So I recommend that you just really make sure that you can go from this step to this step, review that, rewind the video and have a look at that step, because that's really important and very easy to make a mistake in going from there to there.